Hello and welcome to Geometry. Today we will cover section 1.1, Points, Lines, and Planes, and complete the guided notes. Here I have the textbook PDF at the top of the screen and our guided notes at the bottom. Go ahead and turn to section 1.1 in the guided notes. I will be assuming that you have already completed the chapter introductory activity before you read. First thing we will do is look at what we will learn from this section. We are asked to scan the text in lesson 1.1 and write 2 facts that we learned about points, lines, and planes as you scanned. So let's take a look at the text here at the top. We'll start with an introduction of what are points, lines, and planes. It mentions undefined terms. There's a diagram here that we might recognize from algebra class. And then we see point, line, and plane are defined, and there's a diagram to go along with each one. So I'm going to take my first fact that I find right out of here. We'll just look at this first key concept. I know that I'm going to be completing the vocabulary in the next section, so I won't use simply the definition of a vocabulary term as my key fact. That would seem like a little redundant. But I will take a note here and say that points are named by a capital letter here. And if I notice there is a lowercase letter over here next to the line, so maybe lines are named by 2 points on the line or a lowercase script letter. So maybe that's my first fact. Points are named by capital letters, lines are named by lowercase script letters. So we can go ahead and write that in section number 1. Point is named, it said by a capital letter. There should be a semicolon there. A line is named by a lowercase letter. I didn't have room to write the word script. I think that'll be okay. These are just notes. They do not need to be verbatim. Let's keep going. We've got something about collinear, coplanar. We'll come back to that. There's an example here about naming. Looks like it says to name each of the following lines and planes. So we'll come back to that with the examples in part 2. Another video, real world career. Hey, there's this stuff on the side. This is a good fodder for facts here. Drafters use perspective to create drawings to build everything from toys to school buildings. Drafters need skills in math and computers. They get their education at trade schools, community colleges, and some 4-year colleges. Okay, so we might consider summarizing that into a fact there. Part 2, intersections of lines and planes. Definition, example, study tip, define terms in space, 4th example, and then check your understanding. So this begins the homework exercises and questions. So that is the end of the section. It's fairly short. Ooh, I like this. This little study tip. This is another good source of some facts we could put in here. A point has no dimension. A line exists in 1 dimension. However, a circle is 2-dimensional. A pyramid is 3-dimensional. I like that. Let's use that for our little fact-finding hunt. Here we've got a point is 0D. Okay. A line, let's change this to a colon so I'm not using the same symbols too redundantly. A line is one-dimensional. Okay. A circle is 2D. And a pyramid is a 3D shape. Okay. There we have our 2 facts scanned from the text just to give us an idea, a summary, what stood out to us, what sounds interesting. You are free to choose whatever facts you like there. Now, on to the vocabulary section. So we will go back to the beginning of the text and go through. This text includes both a list of all new vocabulary terms in the section that will match our list down here, as well as it will highlight all the terms for us. So we should be looking for these yellow highlights here. So I will start at the beginning. I'm going to go through and read the entire text out loud for you, and when we get to the vocabulary terms, we will stop and write those down. So, number 1, points, lines, and planes. Unlike the real-world objects that they model, shapes, points, lines, and planes do not have any actual size. In geometry, point, line, and plane are considered undefined terms because they are only explained using examples and descriptions. Okay, it's a little tough because it's in the middle of a sentence, so I'm going to skip the because. Undefined terms are only explained using examples and descriptions. So that is what I will write here for my definition. Only explained using examples and descriptions. I have pre-written these definitions to save time. Go ahead and pause the video while you write that down. Okay. Continuing on, you are already familiar with the terms point, line, and plane from algebra. You graphed on a coordinate plane, found ordered pairs that represent points on lines. In geometry, these terms have a similar meaning. And there is the reference diagram again. The phrase exactly one in a statement such as there is exactly one line through any 2 points means that there is one and only one. You cannot create 2 different lines through the same 2 points. You will just be tracing over the same line. So let's go ahead and zoom in here on the text. Key concept is undefined terms. If you see this box, odds are you're going to be adding it to your notes in some fashion. Right now we have some terms. A point is a location. It has neither shape nor size. It's a location, neither shape nor size, so I will add that to my notes. As previously mentioned, it is named by a capital letter. For example, we have point A over here. It's just a dot on the page and capital letter A nearby. A line is made up of points and has no thickness or width. There is exactly one line through any 2 points, named by the letters representing those 2 points on the line, or a lowercase script letter. So for example, this line here on these 2 points, we can call it line M, or we can call it line PQ, or this is still would be said line PQ. Note it has the symbol above that just shows an actual line. Or since the order doesn't matter, we could call it line QP or line QP again. So for my definition here, a line made up of points has no thickness or width. This second sentence here is a further explanation of a property of a line, but is not part of the definition itself. So made up of points has no thickness or width. And finally, we have a plane. A plane is a flat surface made up of points that extends infinitely in all directions. There is exactly one plane through any 3 points, not on the same line. A plane here is this parallelogram shape. Please do try, if you are drawing your own plane, to make it not just a simple rectangle. Don't make a perfect rectangle. Give it a parallelogram. Give it some angle there so it looks like you're looking down at a sheet of paper lying on a desk, at a slight angle there. We will name the plane by a capital script letter or letters naming 3 points that are not all on the same line. That is important, and I will need to emphasize that. You need at least 3 points to name the plane. Otherwise, with just 2, you'd be naming a line. So example, we can call this plane K, or we can call it plane BCD, or CDB, plane DCB. The order doesn't matter here, as long as you have all those 3. And you'll always precede it with the word plane. We're not going to draw a whole little plane symbol above each of those. So there we go. Flat surface made of points that extends infinitely in all directions. Right. Now that we have those 3 items defined, we can start to do some things with them, such as collinear. Collinear points are points that lie on the same line. So that's our next term. Points that lie on the same line are collinear. It literally has the word line in it. I suppose if you and a friend are sitting on the same couch, then you are co-coucher. Non-collinear points do not lie on the same line. I think that is pretty self-explanatory. Coplanar points are points that lie on the same plane. Once again, we have the word plane inside the word. Non-coplanar points do not lie in the same plane. So coplanar, very similar to collinear. Same line, same plane. And I will pass these examples by. We'll return to those in part 2. Next topic, the intersections of lines and planes. The intersection of 2 or more geometric figures is the set of points that they have in common. 2 lines intersect in a point. Lines can intersect planes, and planes can intersect each other. This is where the diagrams will start to get a little tricky. Lines crossing here, intersecting at a point. I think that one is much more easy to visualize since this itself can happen all on the same page. 2 lines, lines L and line M, intersect at point P there. The planes, so you have to think of this is a horizontal sheet of paper here in green, plane A, and a vertical sheet of paper, plane B. And we've done some sort of an origami trick here to have them cross through each other, and that intersection between the planes there looks, well, I don't want to spoil it, but I'll spoil it here. It looks like it's going to be some kind of a line. So I need the generic term for any intersection. So the set of points held in common of 2 or more geometric figures is any intersection. I'm not going to be particular to intersection of lines or planes for that definition. All right, when we have just 2 more to go here, so we will return to the examples later. We need to get our final terms. We are defining definition. I know it sounds strange, but true. Definitions or defined terms are explained using undefined terms and or other defined terms. We will contrast that with the undefined terms themselves a little bit later. And then space is defined as a boundless, 3-dimensional set of all points. Space can contain lines and planes. Space, then, being the 3-dimensional set of all points, is basically everything left over, at least as far as we are concerned in the real world in which we live. So here's my definitions, explained using undefined terms and or other defined terms. and space is a boundless three-dimensional set of all points. So if a term is defined, then within that definition, you can find other defined terms. Have you ever looked up a word in the dictionary and they use something in the definition? You have to look up that word again? That's what we mean. We can have defined terms inside the definition. We can also have the undefined terms in our definition, but that would be the stopping point. Once you've gotten to an undefined term, you can't then look that up. There's no more definition to find. And after example 4, that finishes the text there. But we're not done with our notes. So on to the next page. We need to represent the main idea here. We want to model these things. Let's create a visual representation here. Model a point, line, and plane with a representative drawing. Label your drawing. We've seen several of these in the text already. Here's one in example 4. Here's a simpler one, actually 2. You could take your algebra Cartesian plane as a model. We've got a more complicated intersection of planes there. And you could even get fancy with it and draw a real-world representation. But I'm going to stick with something more like this. I'm going to draw a plane and maybe a line on it and a line through it. So I will simply go 1, 2, 3, 4 lines there. That creates my plane. We'll give it a script capital letter, call it capital M, and we'll make a line going across it, put the arrows on both ends, and we can call that lowercase script L. And we need a point. We could do a point. Let's go over here, and we'll call that point capital P for point. So we have a point, a line, and a plane. This is the absolute bare minimum they asked for. It didn't say one had to be on top of another. You can put your point on the line. You can put your point off of the plane. You could even, I'll use a different color here to differentiate. You could even draw a line through the plane. Although if you do this, I recommend, since it looks like it would go through the plane, I'm going to have this one intersect line L as well. We'll call this, I don't know what a script J looks like. We'll just come up with another letter there, lowercase. But if we really want to sell the illusion that this goes above the plane through, like poking a pencil through a hole in the paper, then what I want to do with this portion of it, since this would, if this was a physical model, this portion of the line would be hidden. So I'm actually going to turn that portion into a dashed line there, so that shows that this portion of line is actually behind the plane here. But that's way more than we really need to do at this point. All right, now for the intersections of lines and planes, we're going to compare the undefined and the defined terms by completing this table, provide both definitions and examples. So I want to again represent my definition that I wrote earlier, a defined term and an undefined term. So remember, the defined term was explained using undefined terms and other defined terms, but the undefined term used only examples and descriptions. So defined terms, definition, explained with defined and undefined terms. Undefined is explained with examples and descriptions. So a defined term could be pretty much any of our vocabulary except for the undefined term. So why don't we start with that? We know an undefined term would be a point or a line. A defined term could be collinear, or even space actually was a defined term. Only point, line, and plane were the undefined terms, because we have to start somewhere. If you tried to come up with a definition of point, you would have to use other terms, right? Other words that have some meaning there, and then you'd have to look up those definitions. What if you didn't know what those meant? So at some point, we have to get back to an undefined term as a starting point. So we've chosen for geometry to use point, line, and plane as our undefined term starting point. And finally, helping you remember. Recall or look in a dictionary for the meaning of the prefix co. What does the prefix mean? How can it help you remember the meaning of collinear? I forgot that there are two L's in collinear. We'll fix that there. All right, what does the prefix co mean? Co means with or together. And if I remember my high school Spanish class, I believe the Spanish term preposition con is the same thing, with or together. And so that can help us remember the definition of collinear if we think that collinear, we can think of it as together on the same line. Now I'll put that in quotations as well. So you've got the co meaning together, and you have the I don't need the full linear. We 4 letters right there, line on the same line. This concludes the guided notes for section 1.1. Come back for part 2 to complete the example problems from this section. So long, farewell, enjoy the rest of your day.